Sorry. Oh, push it back. Yeah, if possible. Okay, so the people behind you, it does feel really connected. I think the one thing is like, yeah. So like, I have a, is it like, I know someone there.
You should download French takes.
So then you could probably test it. I don't know. I don't know.
All right, everybody, let's go ahead and get started. There's a decent amount for us to cover, and I want to give enough time for the in-class activity or two today. All right, so to start, let's just do a round of time guesser again, and then there's one other game I want to I learned about over the weekend, and so we'll do that. Oh, this one seems pretty interesting. Okay, so it's in black and white, so maybe it's a bit older, but where do we think this could be?
That's when it tricks you. That's when it gets you. It's in 2024.
Okay.
1930.
It must be some. Let's do the location first. We'll do this maybe in like 30 seconds. Where do we think? Has to be somewhere near the water.
Moscow.
Moscow. Maybe somewhere tropical. I don't know. Looks like lighter port. Okay. Any guesses? I'm just gonna like listen to what one of the first ones that I hear.
Mexico City.
Mexico. Okay, I think Mexico City's not on the water, but that would be great. Let's do a reasonable one that's close to the water. Something. Any guess?
New York
Okay,
City.
I mean, the person is wearing. I don't know how to tell the location from this, but it seems very
The
like
time should be 1930 or something.
1930.
That's the official outfit for that time. No,
Yeah.
actually.
Okay, what do we think for the time?
I'm gonna say
1930s. Okay, let's just guess 30s and see.
That's
Let's
like
do 1933.
It's like Peaky Blinders stuff.
There's no way it's in here. Oh, New Zealand. Okay. And we were it's 1900. I didn't even know. I don't know what the camera technology is like at different points in history, so this is somewhat educational as well. Okay, so let's get into it, starting with some. Oh wait, sorry. There's one other game I wanted to show. Okay, this game is called Angle. All right, it's not actually a geography game, which I said I would try to do to start each class. This is just a game. If you're really thinking for some game to play, it basically shows you an angle, and you just have to guess how big this angle is, okay? So like wherever this like circle is, that's the angle of interest, and then you have 4 guesses basically. So like this one, is probably over, or it is over 180 degrees. So someone wanted to just guess a number.
210.
210. All right, let's guess 210. All right, so okay, we're really close. It'll say like these different scales, but it'll also say if we have to guess higher or lower.
213.
213? Yeah, I think that might be. Oh, that's right. Okay, nice. Good job. All right, that's angle. Let's move on now. So, some announcements. The Project 2 grades are released, and generally people did very well. I think like almost everybody got 93 or above. Okay, and I have a rubric here that is sort of how we're grading these. Okay. One thing I want y'all to keep in mind is that grading a pull request, it's not like, running a bunch of tests and just making sure things are correct. Think of it more as like grading an essay, right? Where we have these different criteria for how organized it was, how, compelling the narrative is, how good the evidence or claims are, okay? So this is what we have come up with as a course staff that we think is like a fair way to grade this. You'll notice I covered the requirements as only one of the 4 things. The next one is code quality, and then the process journal and design document, okay? Generally, people are going to get 93 or 97 in most of these categories, and that's why I think most of the grades are between 93 and 97. And also keep in mind, Project 2 is worth 10% of your grade, so like getting a 95 versus a 97 is like 0.2% of your overall final grade, okay? So these distinctions, they're not going to have a huge impact on your final grade, but if you do have, an issue with one of the grades, with your grade that's online, you can make a private STEM post, you can come up to us in like office hours or tutor hours, and we can sort of go through the rubric for your assignment. But generally, those were pretty good submissions, and I think almost everybody made the changes that we requested. Yeah.
So like some of these, like the process journal, if we look at 97 says good process journal, his main details. Is that from the first, from before they look at?
This will be for after, like after the changes requested. That's how we grade the process journal, the design document, and the requirements. The code quality, we did that based on like the initial submission, like the number of changes that we requested. Okay, yeah, let's go there.
So code quality meaning like all the design aspects, because in the first for like the request, I guess I got like, oh, put the design things on your file, and the next one I got, oh, your code is kind of wrong. But then for both I didn't get code quality, but I still got like.
Yeah, so I mean we might have not have mentioned code quality, the term in that requested change, but if you had like extra new lines, or if you used the like creating a constructor or passing in a parameter, those we counted as like a code quality issue basically. So the number of changes we requested on that is how we decided this. Let's go here and then.
So what if you get 95? What does that mean?
If you got 95,
Some of each?
yeah, you probably had like a couple 93s and a couple 97s.
Alright, thank you.
Yeah, you're welcome. Yeah, question.
So the nice to have features is what gets you 100 on.
Yeah, for that one. And I think generally, like, some people did get above a 97. They either did the extra requirements or had like a really good design document and process journal, so that's how you would score higher, okay? Are there any questions about this? Again, you know, most people, almost everybody's got an A, like a regular A, not even an A minus on this. But I know we had Project 3 due last week, and I think for some people, Project 3, you were like working up until the deadline, and that is totally fine. I think, you know, in some sense, you got like an authentic like industry experience of like having a lot of projects going on and, you know, some internal deadlines. One thing we want to emphasize here is, you know, as you can see, I think the grades, we will be somewhat lenient with that, right? I think if you get the projects done and hit all the requirements, you will get a good grade in the class. We care more about y'all having the experience of doing the project, okay? So if you didn't finish or you weren't very happy with your submission, remember, we are going to request changes. Our goal is to have all the changes, the first round of review for Project 3 done by like Thursday night, and then y'all will have 5-6 days to make those changes, and that is when you can sort of submit your improved version of Project 3 basically, okay? And so we will take it into account that, you know, in the first deadline you might not have had everything, but we will still use the same grading rubric, and we're gonna give points back for your new submission. So, you know, if you weren't happy with Project 3, please, you know, continue working on it and improve it, because we're gonna grade what you eventually submit. Yeah.
For Project 2, is it possible to see our rubrics?
Yeah, I think we can make that public. We did internally, but I think on Canvas you'll only see the final thing. How is the best way to distribute it? Maybe you can, like, if you post on EdStem privately, we can tell you what your rubric was. If we're getting a bunch of requests, then I'll try to find some way to just disseminate it to everybody. But that's a good question. Distribute to everybody. All right, any questions on Project 3? Okay, Project 4, I think I made an announcement about this on EdStem. This is just that same announcement about the project being extended. I'm not extending it again. It's just the same one from the EdStem post. It'll be due on Sunday night, with the 24-hour grace period being Monday night. From, you know, I think some people have completed it. It is a lot shorter and quicker than Project 3. And keep in mind, we want you to use Copilot and Copilot Chat. And you don't have to submit a design document, okay? I just wanted to put this link here so that you also just read the submission details. There is no design document, and the process journal is slightly different, okay? We mostly want you to discuss how you use GitHub Copilot and your experience using it, all right? And you also, importantly, should upload the chats that you had with GitHub Copilot. There's instructions here on how to download the JSON version of your chat, and then you should upload it for your pull request. Okay? So that's due Sunday night, technically Monday night. Yeah?
Is the intent to try to use Copilot as much as we need to, or is the intent to kind of cover it? So for example, if I use Copilot, but maybe not necessarily to the extent of using all those, I guess, but like,
these, right?
yeah, necessarily all of these, would it consider be like a lesser grade? necessarily.
No. If you didn't use one of these, actually I thought I should have put this on here. If you didn't use one of these, just mention you didn't use it. But still, just explicitly mention
It's
it.
right there, it's the last line.
Oh, okay, cool. Oh, it should have been a new line, but thank you. Yeah, if you didn't use one of these, that's fine, just mention that you didn't use it. Okay? Alright, next, this is something that we just decided as a core staff yesterday, but we updated the schedule to modify sort of how the group final project is gonna go. So one thing that I want to make sure we emphasize is just getting progress on the group project, okay? And now, as you know, we're sort of wrapping up the individual projects, and the focus now is on, you know, using everything we've learned to add a new feature to IDLE, okay? So a lot of the activities we do now are gonna shift more to the final project. And I wanna make sure we have enough time for y'all to, you know, do all the things you need for, you know, a good project submission. So next Thursday, we're going to reserve this in-class period for the actual final project checkpoint, okay? So rather than just making a GitHub issue or making a pull request or anything like that for final checkpoint 1, we're gonna have everybody come to class. We'll maybe have a couple scaffolded activities to help you with the next stage of your project, maybe what we'll do today. We're gonna sort of have a couple activities where you plan as a team. But this is gonna be still attendance, you'll get attendance credit for coming, and hopefully you do come. And that's where we're gonna have the check-in between the tutors and me and the project teams, okay? We wanna make sure we have class time built in for y'all to get help from us, to work with each other, and we'll maybe, have a couple activities to help y'all along. But just keep in mind that there's only going to be this one final project checkpoint. We don't have a final project checkpoint 2, okay? So this is kind of the midpoint of the project. That's where you'll get some advice from us, and then you'll have the next sort of week, and I think 2 weeks almost, to wrap up the project, right? Also, okay, any questions on the schedule or the group project? Okay, so this next one, we're sort of experimenting something out. So UCSD is trying out this thing called Prairie Learn, as a computer science department. We're sort of moving to this learning management system. And what we're gonna do in class on Thursday, okay? Thursday, this is going to be a practice skill demonstration where we're gonna try out using Prairie Learn for completing tasks in a large code base, okay? So it'll make more sense on Thursday when we sort of go over the instructions. For now though, if everybody could actually just go to this link to join Prairie Learn, we just need to make sure that students are actually on it. Yeah?
Doesn't work.
Doesn't work. Okay. That's surprising. Okay, I think I'll have to look into that then. Is Steven here? Steven? You left? Okay. I was gonna ask Steven to work on it, but okay, I'll send out an announcement about it later. But in short, what's gonna happen on Thursday is we're gonna have 40 minutes where y'all should bring a laptop to class. Make sure you have your laptop and it has enough battery. You're basically just going to be doing a short activity in class on the IDLE codebase. We'll have y'all answer a few code comprehension questions and make a small change to the codebase. It'll sort of be, think of it as an assessment, but again, it's not for a grade. It'll just be for practice to use the things that we've learned in the first 5 to 6 weeks of the class, okay? I'll send out an announcement about this later with the join link, but I'm surprised that this isn't working. I'll get to the bottom of that. Okay, any questions about any of these announcements? Awesome. Okay, next, the code walkthrough presentations. We're getting closer to that. I just wanted to cover the expectations of it. So the things that you should do in this code walkthrough demonstration, you should have a couple slides with insightful diagrams that sort of cover the parts of the code base that you're going to be explaining. Think of it as also a standalone piece of documentation, okay? That could exist even without you having to talk and explain the diagram. You should demonstrate some of the code comprehension techniques that we did before, show the debugger, make some small code change, read the test cases or show us the test cases, and then if there's any sort of unique or unfamiliar syntax, you might want to cover that as well, okay? Things to avoid, main thing here is we don't want to just have you showing a screenshot of code or showing some code and explaining line by line what's going on. We don't need to know the code in that much detail. The goal here of the code walkthrough presentation is for you to take some specific part of the code base and explain it in terms that somebody else who is kind of working on the code base can understand. Okay? You don't need to explain every single line. Maybe you can abstract some of the logic away and give us more of a high level understanding of what's going on in that feature. Okay? And I think we only have 3 or 3.5 signups right now. So please make sure you sign up for this before. Yeah, it's happening in week 9, so you still have about 2 weeks. And again, this is a group presentation with your group, so each person only probably has to speak for 3 to 4 minutes. But I would go ahead and start planning this as well. Okay. Next, I think last thing before we get to the content for today. These projects that you're doing in class, I think these are somewhat significant projects that are just things that you can include in your resume. So some of you, maybe most of you, are eventually going to be looking for jobs, and a big part of that is having a good resume that you send out. And I think, mentioning that you've worked on an open source project like this, although you're not technically an open source contributor, you're working on a project that is an open source project. If you do end up making an actual open source contribution, again, remember, you can just go to the CPython repository, and you can actually click issues, and you can see a lot of these open issues that people want you to contribute to. I think there is a type of label for good first issues or easy. You can select that since I think most of y'all are just getting started with this, and a lot of it is actually just improving documentation or making smaller changes. This I think would be really impressive or awesome to have on your resume as well. And you also have the advantage of learning about this code base for 8 weeks, 10 weeks by the end of the quarter, to where you'll I think be able to effectively contribute to the code base. All right. So keep that in mind, that I think this is also something practical that you can put on your resume, and then you can even go even a step further than what we're doing in this class and make an actual open source contribution. Okay. Awesome. All right. Let's go ahead and wrap up the activity from last week. So remember, we were talking about coverage, okay? Or we were talking about tests and test coverage. So we had finished with this activity where I wanted y'all to figure out which lines of code, which test methods cover these 2 lines of code in the history class, okay? So let me actually open up history.py. So let's open this. So we have test history here. That's the test file we're going to be looking at, and then let's just open up history as well. So in the store method, we have, let's see. In the store method, the 2 lines of interest were this source equals source.strip and then self.history.remove, okay? And you're not going to be doing it in this lecture. This was something that we did in the past lecture, but we had to figure out which of these tests covered these lines, okay? And the sort of goal here is that we want to know how much of our code base are our tests actually covering, okay? So this is maybe just a high-level understanding of what test coverage is. I mean, keep in mind, testing is going to be a very big part of whatever job you end up going into. You not only have to write the code to implement the feature, but then you have to write the code, and it might even be more code to actually test the feature, okay? And so there's these different types of test coverage. One is function coverage. What % of functions are we covering through our test suite? Then we have line coverage, what % of lines are actually executed through our tests. We have branch coverage. Remember, line coverage sort of can miss the point of if we're testing all the different edge cases or the possible paths through the program, right? Anytime we have an if-else statement, we want to make sure that we are testing the code inside the if and testing the code inside the else. Same thing with try catch, if you've seen some of those in the code base. We want to make sure that we are able to run the code inside of the try block, but also we should know that our code is handling these exceptions correctly, okay? And then finally, there's statement coverage. I think in a Python code base, statement coverage and line coverage are going to be almost identical, because the main difference here is a statement coverage. There are going to be multiple statements per line, basically. You can think of in Java, for example, you can have like int x equals 7, and then you can put a semicolon, and then you can also have like int y equals 9 on the same line, okay? So in that sense, statement coverage and line coverage can be different, but for generally, line coverage and statement coverage are very similar, okay? So what I'm going to do now is just do a quick demo of running coverage in idle. This was initially going to be an exploration activity, but I actually think this is like a very time-consuming and like frustrating activity. And like I said, I think we should focus more on the group project, and you'll also have a project 4, which wasn't a thing that we did last year in this class. So I'm just going to show a quick demo of this because there are some helpful lessons to learn from going through this activity, but I'll just show like a condensed version of it rather than sort of assigning it for y'all to do, okay? So there is this piece of documentation in the idle code base about how to run this package called coverage, okay? And coverage is actually a well-known sort of Python package that is used to figure out your line and branch coverage of your test cases, okay? And so the sort of lesson that we wanted y'all to pick up here is that documentation in many cases is going to be like outdated. It might not work for you. It might just be inaccurate. And the unfortunate thing with like open source development is that people aren't paid for this, you know, and so sometimes people might get a little bit lazy or forget to like update documentation, and that's kind of what has happened in this case. There's some documentation here about how to run coverage, but this like doesn't work at all, and there's very little information on how to actually get coverage to work for the idle code base. One thing that we were going to give you as like a hint when you're doing this activity on your own is this GitHub issue where the developers, and this is someone named Terry Jan Reedy, this is the person who is the lead idle developer. He was the person that responded to my question about where the idle source code is, if you remember back from lecture 2. This is one of the main people in charge of idle, and there's this sort of open GitHub issue about documenting how to run coverage. Remember, coverage is this package for the idle lib files, okay? And actually, this is somewhat interesting. I'll just spend like a minute on this. There was this person back in like October 2020 who had this like awesome idea to just have a file called test underscore or like run underscore coverage, okay? Maybe I can show y'all somewhere here. Yeah, so they made this run underscore coverage.py file in the idle test directory, okay? And what it was going to do is have like all the correct updated documentation for how to run the coverage package in idle, okay? And as you can see, this was like, oh my god, it's like 4 years ago now. I keep thinking 2020 is like only 2 years ago, but this was like so long ago, right? And you can see something very similar to what we do in the code review process for your projects, right? Where this person will make some changes, and then you can even see some of the comments by the lead maintainer, Terry Reedy here. I mean, you can sort of see like a back and forth. There's a lot of people that will do the code review, not just one person that does the code review. And then there's sort of this back and forth process of the person making edits, okay? So let's just get to the bottom here where we can sort of see all the changes. We can see the responses left by Terry Reedy. And you can see maybe like some clarification questions. Maybe you've seen some similar comments from us. And then at the bottom here, this is the really unfortunate thing. I think it got to the point where they were very close to it being done, but you can sort of see the like open status of any pull request at the bottom here, and it says still like changes requested. I think the sort of final state of this request was Terry J. Reedy had requested some changes, and there was no sort of like follow-up for it or no response to those changes, and so now it's actually just an open. You can see from this previous one. Oh, maybe it doesn't show it, but oh yeah, when you click on the GitHub issue, you can see the status of it as an open issue. Okay, if it was successfully finished and completed, it would say closed here, and it would be like a done issue or a completed issue. We unfortunately didn't get this in like the actual open source project. Okay, so now we sort of have to figure out how to run the coverage package. There was one other hint that we were going to show, which was this awesome person, CS Abella, had like given some helpful comment on how they got coverage to work. I'm just going to like quickly show you what does work and show you the cool feature of coverage, okay? So there are some links here if you are interested in this. It is pretty interesting how they sort of the like way that coverage actually works by running all the different test cases and then tracking which lines get hit by which function. If you are interested, you can read this documentation. But the sort of way that we have to go about doing this is creating something called a virtual environment, okay? Y'all might have worked with virtual environments before. If you've heard of like Anaconda, that's I'm not even sure the right term for it. It's like a framework that manages your virtual environment. So what a virtual environment is at a high level is, say you're like a software engineer, a software developer, you have like all these different projects. Maybe you have your own personal website and you have that like VS Code, or you have like a directory for your personal website on your computer. But then you're also in a CSE 190 class and you're working on the idlib code base, right? And you have like that directory on your computer, and then you're in a few other classes or a few other jobs, and you have like all these different directories for different software projects, but maybe they all have slightly different requirements, right? Like one of them requires you to have like matplotlib or numpy version 3.6, but then the other one you have to have like version 1.8 or something, and then the other one you have to have this like Django framework, which helps you with like creating websites. So virtual environments are a way to sort of like isolate those different dependencies or sort of like subsystems or like bundles of software and keep them separate so that we don't have these like overlapping dependencies, or you can sort of more easily manage your projects and the sort of like libraries or frameworks that they need, okay? So that's actually what the approach is here for using coverage. We have to create a virtual environment, we have to install coverage in that virtual environment, and then use it, okay? So let me just go ahead and show you what this thing actually does. And then we can sort of actually answer this question about which lines in history are run by which methods, okay? So let me hope that, okay, this is already open. And let me just run these lines to show you. So first we have to sort of have coverage discover the unit tests, okay? And what this actually does is it'll run a bunch of unit tests, okay? So you'll see at the bottom here, mine is failing some unit tests. It'll tell you how many unit tests it ran, and then the number of failures, the number of errors, and those that are skipped, okay? I think I have a few changes on here that are like breaking some of the unit tests. So you might not have the same thing when it runs all the unit tests, but this is just unfortunately what my output is right now. But then we can do this awesome thing where we ask coverage for a report, okay? So what we did the first time was we asked coverage to sort of discover all the unit tests and run all the unit tests. And now we want a report on like what is the actual coverage for each file, okay? And by the way, don't try to like do this along with me because there are a lot of setup things that I had to do. You have to create like a separate file called coverage RC and have these different sort of directions in it. So don't worry about doing this. This was going to be an exploration activity, but I think I saved y'all a lot of time by not requiring this, okay? So this is a pretty ridiculous view where it shows like a bunch of stuff in the terminal, and these are a bunch of different columns where it tells you like the percentage of coverage. But I think the sort of cleaner way to do this is by running this HTML command, and then we're going to actually see what, see the coverage in a much more, I guess, better formatted view. So, okay, it says it wrote this HTML report. Let me actually just open it here. Okay, let me close this. So let's go to documents. I'm going to go to my CPython. Okay, we have this HTML cub. It just tells me the output here. It wrote the HTML report to HTML code/index.html. So I'm just going to open that. And here we can see like a better format of this, okay? So one thing y'all will notice is that my coverage report says only 36% of lines are covered. For those of you on a Mac, I actually think most of y'all will see a lower one. For some reason, I think we had this issue last year, I still haven't figured it out, that a lot of the GUI tests on a Mac are not able to run, okay? So if y'all tried running the full test suite, you'll probably see, I can maybe quickly do it. I think a lot of them on a Mac might get skipped for the ones that require GUI, and I truly don't know why, okay? if someone can figure it out, that would be awesome. You can come up and show me if you have a Mac and you're running into these issues. Okay, right now I'm failing some tests because of code outline. But this is what might typically be happening. You'll see this error here that it'll say like skipped cannot run without OS X GUI process. Okay, so that's why a lot of tests on Mac might be failing. And again, I don't have a great explanation for it. If someone can figure it out, that'd be awesome. But you will see basically for each file in our directory the percent of coverage, okay? And so let's just go to history.py, and right now you can see that it has only 31% coverage, and it shows you the things in green, the things that are actually run, and in red, the things that aren't actually run, okay? So it seems like we're missing the entire fetch class, and if we sort of like dig into why this is happening, at least on my machine, we can see that the fetch test requires GUI, okay? And these are the ones that are skipping on a Mac, so that's why all of this is in red. It's not actually detecting any tests checking this code. But fortunately, we do have the store method that is run, okay? And I think it shows us that all of the lines are actually hit, but we don't have the answer to the previous question, which was like, which specific tests are running specific lines of code, okay? And the way to do that actually, let me just run it one more time. Yeah, we just have to generate the HTML report with this show context flag. So let me do that, and it'll take a couple seconds to run. Okay. So now, I think we'll see the same beginning part, but when we go to history.py now, and we click on, and we saw 31%, nothing changed there with the skip test, but now you'll see this thing on the right side, which shows you like basically the count of functions that run specific lines of code. And so the first question was like, which ones run this like source.strip one? I mean, this is actually showing us that all three of those tests eventually run that line of code, right? And what this is actually doing is just, running each of these tests, and it's seeing like which lines of code in history.py are just actually run from it, okay? And as you can see, like all of these are just running the store method, okay? And anytime we run the store method in history.py, it'll actually cause this first line to run, right? But we can sort of tell intuitively that really the main test that is actually checking whether the strip is working is this test store short, okay? Because we're testing out this thing which has like 2 spaces and then an A and then 2 more spaces, and we want to make sure that basically nothing is stored in our history, okay? And so really that's the main function that is checking whether this is working, because if this is working, then the length of the source is no longer greater than 2, it'll be less than 2, because strip sort of takes away the white space on both sides of the A. So the length of the source would only be 1, and then we just wouldn't actually append anything to history. But what our coverage functionality, or what our coverage package is doing, is just checking whether this line of code is run at all. So I guess, there's no correctness for that activity last week, but I think this is a helpful way to see what sort of like test coverage practices are used and how we sort of can quantify rapidly and like at a large scale the percent of code that is covered just by running a few simple commands. Okay, and the other sort of interesting lesson I was hoping y'all could see is just this issue of having to dig into the GitHub issues to like, dive into some documentation and read some of these like long comment chains to try to get to the bottom of how you would actually, figure out how to run code coverage, okay? Are there any questions on that short demo? It could have been a lot longer. There was, honestly, the first time I was doing this, I ran into so many issues trying to figure it out. But are there any questions maybe just about test coverage in general or code coverage, anything like that? Yes?
Just out of curiosity, are the percentages normally that low?
No, so, I should have mentioned this actually. Whenever you go to one of these test files, it actually tells you the coverage at the start of it. So you can like open up each of these. They should be very high. They should be close to 100. And this would be the case. I think if you're on a Windows and it's not skipping any of the tests, you should have the same numbers as these. The reason mine is so low is because a lot of the tests are GUI tests, and that's what's getting skipped on a Mac, and so that's why my coverage is so low. But typically they will be or should be quite high, close to 100. Any other questions about test coverage? Okay, cool. So the next thing I want to quickly show are these things called human tests in idle, okay? So I guess human test actually does sound like it's like testing a product on a human kind of, which is a bit like scary. But this is something I want to show because y'all might be doing something similar for your project, okay? So if a lot of y'all are doing a sort of change to idle that you don't think can be tested easily with like unit testing. So for example, I think show code outline, that is something you could write a unit test for, right? You can sort of mock a text widget, you can add some classes, some function definitions in the mock text widget. You can call show code outline and you can just like sort of catch the output and make sure that it matches your simple example. But there are gonna be some tests that, some features that y'all are working on for the group project that you won't actually be able to write a unit test for, okay? And instead, what you might have to do is run this thing called a human test, okay, in idle. And there's a file called htest.py inside of idle_test, okay? I highly recommend y'all look at this if you're not sure how to go about testing your group project. Remember, we are going to ask you to write at least a few tests for your group project in whatever capacity you're able to. And if you're struggling with that, like come to office hours or in the check-in, we'll sort of talk through ways that you can test your actual feature. But this gives like a helpful overview for how to write and run a human test in the idle code base. And I'm just gonna show a demo of what this is actually doing because it's maybe a bit more simple than you would think. So to actually run this, all you have to do is open the htest.py file and click run. And it's actually like, I don't know, it seems kind of simple here. So really what it does is it just opens up this little text widget, and I wish I could make it bigger. I don't think I can actually. But this just says, let me close all these notes. Okay, so this just says every text insert should be printed to the console or the idle shell, okay? And so when I click this test widget redirector, and then I just start typing something in, okay? I'm gonna type in hello. Nothing really happens, okay? But if we like read this message closely, it just says every text insert should be printed to the console or idle shell. What's actually happening is it's literally just printing stuff out from this htest.py file, and it's showing every single insert, okay? And so the reason these tests, I think, are actually a bit more simple is really all you have to do when you're writing this human test is give some instructions to the person who is running this, okay? So you can see like a couple examples here for, I don't know, let's just see like the call tip window, okay? Remember we covered call tips before. When you type in like print and then open parenthesis, it should just like show something after the open parenthesis. All you have to do for this human test is sort of like, you'll have to specify some file and keywords. I think you can read that in the directions before. But you just have to give some directions, like typing open parentheses should display a call tip, typing the close parentheses should hide the call tip. Here you can see that you just have the instruction, every text insert should print to the console. And the sort of rationale here is that we just have to have a human that reads this, does it, and then just checks that it works, okay? So the reason this is a bit, I don't know, this seems a bit hacky in some sense because there's no actual like quantification or like proof that something works other than the human having to sort of check and verify, okay? And again, this is not the ideal test. Ideally, the tests are the unit tests that we have sort of seen throughout the class so far. But I think these are more for things that they couldn't test through unit tests, okay? Like checking whether a call tip appears. I'm assuming there must have been some sort of issue in automatically detecting that, and that's why we've resorted to a human test, okay? So this might be an option for the group project, how you might have to test something. Maybe if you're doing something like a call to OpenAI API or like ChatGPT API, that might require something that's more of a human test because you might not be able to necessarily check if certain things are happening in the output, okay? So just keep this in mind, and again, this is htest.py, this is in the idle_test file. All right, let's get to this next unit, which is just going to be about project management, okay? So we're going to spend maybe 2 to 3 lectures on this. We're going to cover task managers and just general Git workflow, okay? And before we actually get into that, I want to just go over the project expectations here. So remember, now you're going to be sort of focusing more on the group project. So hopefully you're starting to have some meetings with your group, maybe once or twice a week, either in person or remotely. But the goal here is that we want y'all to be doing some of these things that we're going to talk about in this lecture and some of the things that we've shown y'all already in class, okay? So for example, y'all should be sort of having different branches for different parts of the features or parts of the project that you're going to work on. You should be making pull requests, and you should be giving code reviews to each other. So for example, if you have like, say like me, Kushi, Charles, and Yash are working on a project together, I'll take control of like one sub feature. I'll work on my own branch for that. I'll make a pull request into main, and then but we wouldn't just like automatically approve that merge or that pull request. I would first like request maybe Kushi and Charles to review this pull request first. They'll probably leave comments. They should give comments about code quality, about style. They should maybe ask some clarifying questions. And then there could be like a back and forth, and then somebody should eventually merge the request, okay? So that's sort of the expectation here. And hopefully y'all can start following this. Remember, we are going to be able to evaluate all that in the grading. It's going to be just seen like on the GitHub repository, and we'll have access to the previous pull requests, the Git commits, the sort of like back and forth. So please do adhere to this and sort of make some pull requests, leave some comments, and engage in this sort of like quality assurance or sort of like review process, okay? So we're gonna like help you out along the way. The first way that we're sort of gonna do that is covering something called task managers, okay? So this is something that is really important for helping your team be like organized and plan out all the different components, okay? These are some free to use task managers, but there's also like paid versions of all of these, which please don't get that for this class. You definitely don't have to. I'm just gonna show a couple that I have used, and then I'll sort of demo GitHub projects, which I haven't used before, but that's what y'all are going to be using for the project here, okay? So first is this thing called Trello. This is like honestly such an amazing platform. I use this like for so many things. I have one that's just called Life, which is just like the different things I have to do on a day-to-day basis or for different projects. The way this sort of works, maybe I'll show the demo on this idle task manager. This is like a mock one that I made. So the general way to envision these are like boards, okay? Where we have like cards on a board and we can move these cards from like list to list, okay? So we have a list here called to do. We have then the design stage, implementation stage, needs code review, and then done/deployed, okay? It's gonna be sort of up to your team. You're gonna, by the way, be making one of these, and that's what the in-class activity is gonna be. It's sort of up to you to decide what these different like stages should be, what the different lists should be, and what the different cards should actually say, okay? So you can actually, like on Trello, you can just add another list that will be like, I don't know, about to start or something like that. And then you can actually, oops, let's say, oh no. And then you can actually like drag these different cards from the to-do to the design stage. When you move on from the design stage, you can move it to the implementation stage. And this is sort of a way for you to just visually track the different cards or the tasks that you have to do and where you're at in the process, okay? And then one more thing for Trello actually is that you can sort of assign people to cards. Unfortunately, I'm the only one in this board. This is just like a personal one. But if you're working with a team or have added people to the Trello board, you'd be able to like assign people to the task, okay? And then you can also have like a due date, basically, where you set like, okay, I want this to be done on like Thursday at, I don't know, 4:13 p.m. And then you can save it. And then it'll give you notifications for when the deadline is coming up. And yeah, it's a pretty good way to sort of like manage different tasks and track how the tasks are progressing. This is actually like how some of the large like course staffs. So like for intro CS classes, we might have like 50 people TAing a class, TAing or tutoring a class. We might use something like this. Okay, you can sort of imagine how this would be useful when there's like grade assignment 1, grade assignment 2, and all these different like do this code review, add this to the website. Whenever you have like a bunch of tasks like this, it's much easier to sort of visualize like this. Okay. And then I'm going to show one more example of something called Taiga. This was something actually that I had used in CSE 210 when I had taken it a year ago at this point. But this I think is a bit more realistic and something that you can imagine for like a web-based application. Okay, so we had sort of decided to separate the sort of lines as front-end tasks, back-end tasks, I guess UI, UX tasks, DevOps tasks. DevOps is called developer operations. It's sort of like managing the combination of like testing and automated testing, of branching, of moving stuff from like the development stage to the production phase. That's sort of what developer operations means. I think we're going to cover that a bit next week about what this CI/CD or continuous integration, continuous deployment is. But you can sort of see here that we have these things started as new. We have in progress when somebody's working on them. These little icons are like people actually. Let me get rid of this. And then you can sort of drag it from new to close as you progress, okay? This was actually a really bad project. That's why a lot of things are still in progress. We didn't get to finish them by the end of the quarter. But ideally, you would want most of these things to be closed, okay? And again, each team might have a slightly different version of what the sort of like categories are and what the different columns are. And so that's what we're going to do in this in-class activity. You're going to work with your groups and actually come up with the sort of like task manager, okay? Let me show you a demo of GitHub project first so you can know like what you're going to be doing. And then you can go ahead and get started. And by the way, the thing that I'm showing right now, so like Trello, Taiga, GitHub projects, these are all kind of like openly available tools. But a lot of tech companies, they don't use these like open source projects. They'll have like in-house. What in-house means is like developed by that company. Okay, so like Google, Apple, Meta, like they won't use something called Taiga. It'll be something called whatever the internal developers at those companies created. Okay. In-house just means developed by that own company. And so, the general principle of these is pretty similar, okay? So the idea here is that you just learn how to use a task manager, not so much about the very specific tool that you use, okay? We're just more interested in y'all getting the experience of using a task manager. So what I'm going to show y'all now is how to create a GitHub project, and I think y'all can maybe follow along with this and try to do the same thing. This is the GitHub Classroom website. I think right now I can see everybody's team names. By the way, there are some pretty funny team names in here, like commitment issues, I don't know, it's hilarious. And yeah, so our team is called Secret Staff Team. So if you go to your repository, and then go to projects, okay? Yours probably won't have this one here. It probably won't have it, it's just because I had created one in preparation for this. But let me remove that project. So to actually create the project, you'll go to New Project, okay? When you go to the Projects tab, you'll change this link project to New Project, and then you'll create a new project, okay? And before you click anything, it's gonna ask for a template. I highly recommend using this team planning template, okay? You can click featured or all templates. This is gonna be the top left one, okay? You should do team planning. And I'll just call it like Secret Staff Team Project or something. And I actually think you only need one for this as a group, okay? I don't think each one of you needs to make one, just one of y'all can make one. And I'll do create project, okay? Importantly though, before anything, just go to the settings and manage the access. So one thing you should do is change this base role, okay? This one is that everyone in the organization is an admin in this project. Everyone in the organization is everyone who's taking the class right now, and everyone who took the class last year and like all the core staff. So make sure we change this from admin probably to like no access, okay? We don't want everybody in the class to be able to see, your specific project board, but you want to then invite your collaborators, and you can actually do this by team, okay? So you should put in your team name. I'm gonna put in secret staff team because that's the team that I am. Actually, y'all should also add secret staff team. And make sure you add secret staff team, not super secret staff team, okay? Super secret staff team is something that even I don't know what it is, so don't like actually add that. Just do secret staff. It's actually the one from last year, so it's like a different group of people. But just do secret staff team and then add your team, okay? So whatever, if you were team commitment issues, you would add team commitment issues here, okay? And the role should probably be write or admin. I think admin, you probably don't need to do admin, I think write should be sufficient. But then you would just do invite, okay? And then those people should have access to that project. And then, yeah, so then a couple other features I'll show. I again recommend y'all should sort of play around with this. There's so many different like views and layouts in GitHub projects that you have like so many options here on how you want to best organize this. One thing you should do though, this one is a bit weird, so it's important you follow this, is that all of these by default have a limit of cards, okay? It'll say like 0 out of 5, 0 out of 5. You should actually just change that limit to something that's maybe a bit more, so like 15 or something like that. And you can actually add sort of lists here. It doesn't have to start with to do, in progress, and done. In fact, I think you should change those. I think that's maybe not enough or not helpful enough. So you can, add these different columns and sort of name it whatever you want. You can modify the names of these as well. And then to actually add something. Okay, so this is the important part, okay? Just look along of how to like actually add something, and then I'll sort of like turn you all loose. So when you do add item, let's say we're working on project 3 right now, okay? So all I did here was I did add item. I'm just gonna do, I don't know, let's say the item is figure out how to write to PyShell, okay? And I'll press enter, and now it's created this, all right? It's created an item in the to-do list. What I highly recommend y'all to do, and actually maybe we'll even enforce this as well, is you can convert this to an issue, okay? And actually you should sort of link this to your repository. So let me actually go to our repository here. So when you go to your repository, remember this is how we got to projects. We clicked projects. What we had done was done new project, right? But then you can actually link a project. So you can click link project, and you'll want to select whichever project you created, okay? So here is secret staff team project. It might already be linked because you went through this whole like repository to get there. But once you sort of link it, then you can you'll want to convert this to an issue, and I guess you'll just have to select the repository. Ideally, you would maybe automatically know which repository, but I guess you have to select it, and then you can do open a new tab. Okay, so it's converted this to a GitHub issue. You can do open a new tab, and then now it is a GitHub issue in your project team, okay? And now you can sort of like give a description of like what you're going to be doing. Oh, so importantly, you can assign it to someone, okay? So since we're sort of in this group project, I actually think, okay, yeah, we do have all these people who are in, actually, I don't know. This isn't everybody that's in this project. Ideally, yours would have the people in the project. I think nobody has joined this secret staff team yet. So you can like assign people to it, and that's how you can sort of track who is assigned to which project. And it'll sort of like show up here, right? And then you can see like, okay, this person is working on how to figure out how to write to PyShell. You might have more to-dos. You'll definitely have more people, and they'll sort of drag these along the way, okay? But in this GitHub issue, you can then like modify the description and say like figuring out how to send info from editor window to PyShell, okay? You might want to have a bit more description there, but then you can like update the comment, and now we sort of have this this to-do item that is linked to a GitHub issue that'll have more information that'll be sort of assigned to somebody. And then importantly, when we, the course staff, are looking through the different projects to grade, we can see the different issues, we can see the project, we should be able to see the board and sort of how the tasks are progressing, okay? So what I want to do now is just give y'all time to talk with your groups and create this GitHub project and have a bit of planning on what the different cards are going to be, okay? So this is the actual activity, and I guess you should fill this out. I'm gonna modify this so you don't have to write out so much. Let's just say, what is one of the task cards that you created? Make sure you fill out this activity because I think this will be the only one that you have to do for this lecture. But again, worry about the bit.ly later. Importantly, try to get all of this sort of set up and at least plan out many of the tasks, and you can even assign it to people, okay? So think of this as like the brainstorming or planning phase where you can decompose the problem and assign people to different things, okay? Are there any questions about GitHub projects or what you're going to be doing in this activity? Yeah.
Is this for like the whole project or like a plan for like a week or two?
So you can start with just probably planning the next week or two because it might be a bit hard to foresee what happens in like week 3 or 4. So actually, that's a good question. I wish I was supposed to bring this up when I was going over Taiga. The way these things are actually sort of organized, if you want to just pay attention here for a second, y'all can do something similar, where these things are actually broken up into different sprints, okay? So a sprint is like 2 weeks of work basically in industry. And you don't, like, each of these boards will be for a specific sprint, okay? So you can see, like, sprint 1 of the project, it'll have maybe a bit more exploratory tasks, right? Like, explore the Twitter API, identify a list of front-end technologies, set up a basic front-end, and then sprint 2 will be things where now you finish sprint 1, you know where you're at, and then you reassess, like, where are we at, what do we need to do in these next 2 weeks? And then you'll have, you know, more sort of to-dos or tasks that you create and assign to people, okay? So that's a great question. Let's just plan for, I guess, the next week and a half or 2 weeks until the project milestone, okay, the project checkpoint. But again, it is a bit hard to estimate. Just don't think that you have to plan the entire project right now. Do it for the next couple of weeks, okay? Are there any other questions about the GitHub project? Cool, all right, so talk to your group, turn to your group, raise your hands if you need any help figuring out the GitHub project thing. We'll come around as a core staff and help. But yeah, take the time you need and sort of use this to plan out what the next couple weeks are gonna look like. All right, everyone. I think hopefully this is what most of the hands are about, but I think the students, or like as students, y'all can't add a team. You can't add a team to the project, so you'll just do it sort of individually, okay? So when you go to settings, and then go to manage access, all right? What I thought before is that everybody could like add these different teams, okay? But I think that's not the case for y'all. So instead, just add me, like Anshul Shah, and then you'll want to add Kushi, you'll want to add Charles, I think he goes by Charles in this, okay, Charles and then Yash, okay? So add these 3, you can give us whatever permissions you want, I think ideally right would be best, but make sure you add us and you'll add your team. Oh, is that for your permission? Okay.
To the what?
Yeah, do that in the script.
Which here, you know,
Yeah.
in the left side, in the bottom, in the board,
I think, oh no, there's like one person and then it might go out. So if you were. I was putting on. Oh
Yeah, it's very
this looks like you actually gives us the same thing, but I think you can track it.
Oh, interesting.
We used it. We have that's why I became a product manager and then
Sorry. And then you'll click.
Oh, yeah, I'll talk about that later.
And then there it'll ask you for
I mean, I'm gonna change this. I can do the diagram.
just that has to be in this time. We just have to officially recording.
you find
Oh, yeah. Alright.
Stuff like that, logic of it.
Yeah.
It's like it's since you're not
So yeah.
Oh, it's actually. With all these features, hope I. Let's just say I'm not. Dude, I have this and I have the ethical hacking. Yeah, right. I just finished.
I got
Like how the cloud
Alright, also just one more thing, I think this link now works, or at least we've gotten at least one student to click on this link and it works. So when you can, go to like the second or third slide in this lecture slides and click this link below, okay? That's just to join Prairieland. You don't have to do anything else besides join Prairieland, okay?
Do we each have to do this, or?
Join Prairieland?
No, the,
Activity.
stuff.
Oh yeah, because that'll be attendance. Yeah. So each person should submit a Google.
It's okay, it's all the same task, right?
Yeah. We just want to make sure you.
Wait, problem is, this one. Just go with it. Same with Lee, this is.
What do you think? Oh, we touched on. Oh, we the third one. The fourth question. I haven't done it. Is it well that you get yes.
No, what? Oh, I
It's fast, like, most of the students were
I am door. Oh, here. Wait, where?
We just have to sign in for the
But now it's like.
that was the student like
The ones that maybe also a good idea.
I think so. I don't
Yeah, I don't know what changed. Even Yeah, I would recommend actually.
No, like what?
It's like so that can help.
Monday morning.
You can.
Our apologies.
Yeah, that's what it is.
Oh, I was hoping you would do that. No, I
You're right, yeah.
I'm trying to think. Actually, I don't know. I'd rather
Alright, everybody, let's just reconvene for these last 5 minutes here. So, a couple things I want to emphasize. So one is that this GitHub project is going to be like part of, like what you kind of submit or what we evaluate, okay? So, I think we're kind of like hoping that y'all actually make this whatever is most useful to your team. So I would sort of like highly recommend even modifying this thing from to do, in progress to done. Like for example, I think you could have one that's like, let's just make these modifications. So like you could say something like planned, and then you could do like in progress, and then I would definitely add one for like in review or needs review, okay? Remember, doing code reviews is going to be like one thing that we're checking, right? Like once you make your little change on a feature branch, I'm going to talk about how the Git branching should go in the next lecture. You'll make some changes, you want to make a pull request, and at that point you would want to drag, whatever you are doing into needs review, and then you would want to sort of add somebody to that GitHub issue, right? So like say right now, I was assigned to this, like figure out how to write to PyShell. Then once it gets to the needs review stage, then I'll maybe like add somebody else. I'll say like, okay, now I want Cushy to review it, okay? And then you would add Cushy there. I wonder why it's not saving. Oh, maybe she's not technically on this project yet. So never mind. But it should work for y'all when you do. Oh, it did work there. Okay. So you like add an assignee when you get to needs review. Okay. One other thing I want to show is that if you had existing GitHub issues, okay? So let's say, I think I had here, say you already created an issue before learning about this GitHub project thing. So here's one that I just created called task 1, it's assigned to Charles. If you have an issue and you want to then move that to your project, you can click this thing's settings here. And you can go to like projects, go to settings, and then you can actually add it to whichever project is correct, okay? And once you do that, then you can check, you can assign a status to it. Let's say this one is like planned, for example, and then you should be able to see the corresponding like update here, where now it's added task 1 to planned, okay? So make use of this, like as you go through the project, you'll want to like brainstorm and really think through what are these different like tasks that you want to assign, okay? This gets to like the problem decomposition planning aspect of, adding a new feature, and so please, sort of put some thought into how you want to organize this project and update it as you go, okay? All right, we'll go ahead and wrap up here. We're going to cover Git branching in the next lecture. But for now, remember on Thursday, we're going to do this practice skill demonstration. Join this link before next lecture. And yeah, other than that, we'll end lecture a couple minutes early and see y'all on Thursday. Bye, everyone. So one is like, here's the example. So let's say one you have to add the option should be here. Yeah. Okay, it's like there might be this should your cursor dragging up to let's see. Yeah,